I'll show you what we're going to hopefully get covered today. That's my goal. We're going to do section 2.1 today. So I'm going to go over some of the things that are in the homework. We're going to do something like question 2 from the homework, which is estimate the slope of a tangent line at a given point P when you're given a function. We're then going to look at how we can use a table of values to estimate the same thing. And then the last bulk of questions are essentially calculating average and instantaneous velocities. And there's going to be a lot of different, if you can bear with me, there's going to be two techniques used in question 2 where we're given a function. So let me start off by giving you an example of what question 2 might look like. I put little asterisks on something when it's similar to a homework question. Let's have a function f of x. It's going to be 2x plus 4 over x plus 1. And we're interested in the slope of the tangent line at the point 1, that's 1, 3. Okay. So your question 2 in homework will look very similar like that to that one. And they phrase it a really weird way. So I'll write down what it looks like, and then I'll tell you what it really means in English. They tell you that Q is that guy. And then they give you a whole load of questions where they tell you who Q is. Well, actually, they only tell you who the x coordinate of Q is. So they tell you that the x coordinate of Q might be 2. And then they'll tell you it's 1.9. And then they'll tell you it's 1.99. And then they'll tell you it's 2.01. And keeps on going on forever. It's a 2.1. And then to finish with, it might be, I don't know, a 2.5. I just went the wrong way, didn't I? Didn't I just go the wrong way? Darn it in space. I've got to focus here. 2, 1.9. 1.1. There we go. 1.01. And then 0.99. That's better. And then something like 0.5. So essentially, you start off with values that are bigger than this, and then you home in on 1, and then you drift the other way. So you're going to be finding a whole load of different slopes from P to Q using this function and this value of P. So let's show you the first one. I want to do it to 2, what would that be? 2 2s is 4, 8, 8 over 4 is 2. And we are going to find the slope joining P, which is fixed to the various Qs. So in this case, from 1, 3 to 2, 2. And to get the slope, I'm going to use this formula. The difference in the y coordinates of P and Q divided by the difference in the x coordinates of P and Q. And this guy here is xp, yp, and this guy here is xq, yq. So the first way to do it is basically just by hand. So if you do the y coordinate of Q, it's 2. The y coordinate of P is 3. The x coordinate of Q is 2. The x coordinate of this guy is 1. You get -1 over 1, and you get the answer -1. And that's you done the first question. And then the second one would be 2, let's say 1.5. I'll change my question. So suppose it was 1.5. So difference in the y values, that's basically the rise. Difference in the x values. So I'm going to have to calculate that guy. So I'll do a bracket. 2 times 1.5, add 4, close the brackets, divided by 1.5, add 2, and the answer, well, go figure, nice answer. So it's going to be 2 take away 3. That can't be right. 2, 4, 8. 8, that's correct. 1.5. Wow. Isn't that amazing? That's sheer coincidence, same number. So continuing with what I was doing, what we got here then is the x coordinate of q, which is 1.5, take away this guy, x coordinate 2, take away 1, there we go. And the answer I get is -1 over that 5 is -2. And you keep doing that until you've done all 7. That is going to take forever and a day, agreed? Especially if there's 7 of them. So I'm now going to show you how to do that using the calculator. So if you can bear with me for a few minutes, you might want to, when you're doing this thing, you might want to do a pause on the video when you see it. So you go to your calculator. Hopefully, are you seeing a big version of calculator on the screen right now? Okay. You make sure your calculator's on. You go y equals, and you type in your function. In our case, it's 2x. Oh, no, it's not. Can you see this function is 2 over 3 minus x? Let me do that guy. Bracket 2 over 3 minus x. So 2 divided by bracket 3 minus x. That's better. Okay, so I've changed the function from the one I did because I meant to do this one and I wrote down the wrong one. So can you see 4 minus x and 2, 3 minus x? Can you see this on the screen? Because I get right, okay. Can you see the calculator on the screen? Okay, so we can, essentially you can see both things at once. That's helpful. So you type in this function into your calculator as y1. That's done. What you then do is you hit variables. Oh, sorry, let's do that again. You go bracket and you do variables, function, and you get y1. So I'm going to evaluate the function at 3.9. So the value of the function at 3.9, take away, then you do that same variables. You have to have a few buttons, but this takes just a few seconds to set up, and then it's a lot less work. And then you do 4. So it's actually 4. So that's basically y q take away yp in brackets, divided by, put in another bracket, 3.9 take away 4. Right, so this is a new function, so don't expect the same answers as the ones I gave you because I wrote down the wrong function. But for this function, p being 4, -2, and Q being that guy, we can now go and hit enter. And so the first answer is 2.2. So I'm going to do this, although you can't see me doing it. This is 2.2. Now that probably took longer than doing it by hand, but watch the trick now. Second enter. The next one has to be 3.99. Just go to that thing there and insert 9. And then go to here. I would just do 3.99, take away 4, it's quicker. Now, do you see I've now changed it to the next answer, and it only needed to, alter a few numbers. And now the next answer is 2.02.
How come you change it to 3.99?
Simply, let's put it back in. Well, just go there and just type it, 3.99, take away 4, just right on top of what was there. I'll show you the next one. The next one is 3.39, right? Okay, so second entry, scroll to the first guy, which is 3.99, because that's the new fella. Just insert a 9. And then go here. Actually, I could do that as well. Insert a 9. And that will get me this answer. And you keep doing that for this guy and for that guy and for all the other guys. And for instance, at 4.1, that's going to involve a little bit more work. To do 4.1, I'm going to have to rub out a whole load of numbers. So I'm just going to hit delete, 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 and then I should be able to just go 4 and then insert 0.1. Oops, I thought I hit 0.1. There we go, get the 4.1. And then I could just rub this out, 4.1, and delete the extra. That's it. And so at 4.1, for example, I would get the slope at 1.1818. Now, imagine we did every single one of those guys. This is what it would look like, roughly. At 3.99, right? So when I used a Q value of 3.99, the slope came out at 2.2. At 3.99, excuse me, I'm going to take out some background sounds. There you go. So if you'll have to hit the space bar now if you want to say something. So where was I? Yeah. Can you see that there's a distinct pattern as you choose Qs that are closer and closer to P, right? So at 3.9, you get a slope of 2.2. If you go a little bit closer and do a Q with an X coordinate of 3.99, you get this. And if you do this one. So if you were going to be a gambling person, based on this pattern here, what would be your best guesstimate for what you think the slope of the tangent line at P would be?
It looks like it's going to 2.
I would agree. Always go for the obvious in these questions. So if it's 1.99998 kind of thing, will you call it 2? If it's 2.0007, will you probably call it 2? That kind of thing. If it's 1.498, I'd call it 1.5 probably. You know, if it's 1.507, I'd still call it 1.5. They go and they do some other values like 4.01 and things like that as well. And if you did those guys, you would probably find, I'm making this up, that you get an answer like that. Do you see that as you approach from either direction, aren't they both homing in on essentially 2? Would you agree? That from one side it's getting really close to 2, and then the other side, as you move upwards, it's getting really close to 2. And that's pretty much the numerical trick or way of coming up with a guesstimate for the exact value of the slope of the tangent line. Take your function, and that's fixed, but pick values of q that are closer and closer and closer to 4. And what you should discover is that the slopes get closer and closer to one specific value that you can use. Any questions about that one? Are we good with how you would go about that particular kind of question? Okay, so let's clear that off, make that go away. Let's look
I
at
get my
tape.
calculator to do what you did, but
Watch the video again and take it slow, because there's probably one button that you missed. There's a lot of buttons going on there, and you need to kind of play with it. So let's look at examples of using tables of values. And there are 2 questions on the homework that do this, and these are 1 and 6. I'm definitely going to make up my own one this time, because I think I can get away with it since it's just a table. And in this story then, you've got a tank, and there's a hole in it, and liquid's coming out. And what you're going to do is you're going to try and estimate the rate at which water is leaving the tank at various times. So here's 5, here's 10, here's 15, here's 20, 25, 30, and this is time. And you get the volume. And you start off with 1,000 gallons, and now you've got 900. That's probably a bad idea. Make that 500. Yeah, that's more realistic. And then you've got 200. And then you've got 50. And then you've got 20. And then you've got 5. And then you don't have any. So can you imagine that over a 30-minute period, that tank loses all its liquid? Now, it started off with 1,000, right? After 5 minutes, you've lost half of it. Do you notice that the amount that gets left is decreasing, but isn't it decreasing at a different rate? And that kind of makes sense. If you had a big full tank of liquid and there was a hole in the bottom, wouldn't it shoot out really quite high rate at the beginning? You might be losing, 50 gallons a minute at the beginning. But see, towards the end, isn't it just trickling out? And you might only lose a gallon a minute. And so that when you are finding, in this particular question, if you're finding any particular rate, you're looking at what is happening as time goes by, and it's going to change. Now, in this question, there's going to be a fixed value, and in the question I'm doing, it's going to be 1550, right? Essentially, that guy. And we're going to be asked to find, a whole load of calculations. But the slope from this point to Q, and Q is going to be 500, and then it's going to be 10, 200. I can't use that one, that wouldn't really very useful. that guy, that guy, and that guy. And here you put your answer. So let's show you what your working is like. Let's suppose I wanted to do the slope from this fella who's fixed to this fella. Well, the slope is basically 500 take away 50, 5 take away 15, and that's negative 45. And let's suppose I did this one then. So it would be from 1550 to 10200. In this case, slope would be 200 take away 50, 10 take away 15. What's that? That's 150. If I figured this out in my head, 150 and 5. I think it's negative 50 here. And so on and so forth. Let me just double check something here. 500 take away 50. What's that guy? Yeah, that one's good. And the second one then is 150 divided by that guy. There, now I'm happy. Thought that looked a bit out. Negative 30. Right, last one. Let's do this guy to that guy. Well, the slope is going to be 20 take away 50 and 20 take away 15, and that's negative 30, and negative 30 over negative 5, negative 30 over positive 5 is negative 6. And this guy here will be a number, and I don't know what this is, so can I pretend that I know what it is, right? Just making up numbers so I get a table. There's two you'd have to do to find out. So what we have is this table, and that's the first part. That's what question A wants us to do. And now we are going to use this table to estimate the tangent at P. And you should say, well, wait a minute, there's really not a lot to work with here. And I agree with you. They go on and tell you to use two values. Would you agree that these two values are the closest to P? 10, 200 on one side, 20, 20 on the other, right? So somewhere between negative 50 and negative 6. Well, it is only going to be an estimate, right? So wouldn't the best bet be, it's not that number, it's not that number, but it's probably some number between these two, right? So wouldn't the simplest thing be just to find the average? Right? Add them up and half it. So if you add them up and you half it, you get about negative 28. So our best estimate for the slope of the tangent line using this table at this given point is about negative 28. So what that means in practice is that if you were watching this tank and you had the 15-minute came up on your watch and you were measuring with some kind of valve, at what rate is the water shooting out at the 15-minute mark? It'd probably be shooting out something like 28 gallons a minute. So you really, as best you can, you're estimating what the rate at which the water is leaving the tank at a fixed point. So in this case, the slope is actually a measure of the rate at which water is leaving. So in this range here, isn't the water leaving quite fast? Right, 45 gallons a minute. I fixed that. Now it's 30. Now it's 6. Now it's 3. Now it's almost nothing. Does that kind of fit what you'd expect to see in real life? Wouldn't it be shooting out at the beginning really fast and then it'd be dribbling at the end? And that is how to do tables. Takes longer. It's not really hard mentally. It's just messy, right? Takes a long time. Any questions?
How did you find the estimate again?
I just took these two answers here and I averaged them out. So I can't count. Did you notice that? It's 36, so there we go. It's 18. It's because I made a mistake here, I didn't transfer it. Did that help?
Yep, thanks.
Right. So what we're going to...
Would
Yes.
you do that one differently if it wasn't 15? Like that X value is right between those two. So
Yes.
would you do it differently if it was like 17 or something?
I'm not sure you'd be able to find a sensible way to do 17. You could tweak it a little bit for 17, but this is a pretty crude technique. So I would only use this technique, for instance, if I wanted to find values at various places. I would only do in the middles, you know.
All right.
So I could use it for 15. I could use it to estimate, you know, other values. 17 would probably, you'd need to do a thing called linear interpolation. But I wouldn't, I don't think. I don't think there's enough information in that table. You know, imagine you did a table like this and you came up with an answer that had 8 decimal places in it just because the way the numbers came out. Just because the answer has 8 decimal places, does that really mean it's accurate? No, it just means you've got a very bad estimate that you've decided to write down to 8 decimal places. On the other hand, when we did this, if you give me a function, couldn't I get an answer to 8 decimal places by picking a Q that is so darn close to P? You know, that the two would be almost on top of each other. So in a information where you give me a function, I can be really confident about how accurate my estimate is. Can I make it really, really accurate by picking a Q that's really, really close to P? On a table, I really don't have that. Don't I just have the numbers I've got and I'm stuck with it? And so the accuracy I can get from a table is very limited. Very, very, very crude estimate. So our last thing that we want to do are what are called average and instantaneous velocities. So if you've done physics, you're probably aware of this, but I'll give you a quick background. Let's suppose I take an object and I throw it in the sky and it comes up and it goes down. Now, if this is the 1 second mark, this is the 2 second mark, this is the 3 second mark, this is the 4 second mark, and this is the 5 second mark. Can you imagine that would be the path of an object if you threw it up in the sky, right? Right. At the 1 second mark, it's at this height. At the 2 second mark, it's at this height. At the 3 second mark, it's here. Right. Now, if you take the 2 second, oh God, I've got to get better eyesight. If you take the 2 second position and you take, say, the 3 second position, from here to here, isn't the object traveling at a different velocity at the 2 second mark than at the 3 second mark? Think of what happens when you throw that ball in the air. Isn't it going really fast at the beginning? But isn't it then going to get slower and slower? In fact, what's the velocity of the object when it reaches the top here? Theoretically, at least.
0.
0. If you throw something up in the air, isn't there like an instantaneous microsecond where it looks like it's floating in the air before it heads down? Now, the average velocity then, right, is not the velocity at this point or the velocity at that point, which we call instantaneous velocity, but it's actually the average of those two. And here's the cool thing. Do you know the slope of the line joining those 2 points is the same thing as the average velocity? So the slope of a line is the same thing in this context as the average velocity. So here's my formula. The average velocity is going to be the change in position change in time. And we are going to do 3 questions. Well, we're going to do 1 question, but it's essentially going to be the same kind of thing, where we're going to find the average velocity for the journey of a rock being thrown on Mars. So the formula, this is like question 3. The formula is y, the height, is 8t, take away 1.86 t squared. And the first question is the average velocity from 1 to 2 seconds. And they just write it like that. So we're going to find the average between 1 and 2 seconds. And we get that by finding the value of the function at 2, take away the value of the function at 1, divided by 2, take away 1. Essentially, isn't that the same thing as the rise over the run? That's why the slope is the average. Are we okay so far? Now, do you recognize that guy as something that I did on a calculator not that long ago? So I can do this 2 ways. Do you know I could just find the value of this horrible thing at 2, take away the value of this horrible thing at 1, and then divide it by 1. But since I am going to be asked to do a lot of these, for instance, the next one is going to be the average velocity between 1 and 1.5. And then the next one after that is going to be the average velocity from 1 to 1.1. And you can kind of get the gist of what's happening here, right? You're going to make the difference between these two smaller and smaller. In other words, the average velocity between 1 and 1.01, isn't that going to be really close to the instantaneous velocity? Right, the instantaneous velocity is what's happening at the 1 second mark. Now, since I would like to use a calculator to do that, let's see if I can do it on this screen. That way we have both at the same time. I go in here and I type in 8x, because I don't have a t, take away 1.86x squared. Right. So whatever this is goes in as y1. This calculation here, right, is y2 take away y1 over this. On our calculators, although I don't necessarily write it when I do it in paper, I need brackets around things. So brackets. To get this fella, you go variable, scroll over to that guy, choice number 1, enter. And then you put a bracket to close the brackets. Subtract variables over here, that guy again, number 1, that's that done, divided by, in brackets, 2 take away 1. And the answer is 2.42. So from 1 to 2 seconds, this object, right? So basically from here to here, is going upwards about 2.42 meters per second, right, on average. Right, you want to do the next one. It's going to be 1.5, take away 1, right? That guy. Well, second entry, scroll to the 2, and do insert, second button, insert, and type in 1.5, and then delete the extra. And I'm just going to go 1.5, take away 1. And it's 3.35 now. And if I do 1 to 1.1, should get really quick at this, shouldn't I? .094. And one more, this one. I'll just insert a 0 and insert a 0. And I got 4.2614. Actually, I'm going to do one more. 1 to 1.001. There. One last shot. So 1 point. Insert one more 0. Insert one more 0. Now, what we've got here is the average velocity from 1 to 1.001. Would you agree that that's probably going to be very close to the instantaneous velocity? Now, if you want to do your answer to estimate the instantaneous, you could write down the whole thing. Or you could just call it 4.3, couldn't you? Both are correct. I'm looking at the homework. The homework doesn't give me any accuracy. Oh, I take it back. 2 decimal places. Now I have my answer, 4.28. So everything goes to 2 decimal places, including this. Right. And so wouldn't my best guess would be that fella. So any questions about that? As I said, you will probably want to watch the video on how to do the calculator function thing, right? If you want to do that. You don't need to. Can't you just do it the good old-fashioned way and get all the bits and calculate them and subtract them yourself? It will be the same answer, so it's not a big deal if you do it that way. So let's show you. I'm glad that you're still with me, because that's pretty boring. Let's try this. Can you see the homework screen right now? Okay, good. So an example of what I just did is this one here. I'll make it a bit bigger. Might be able to see it better. Yeah. Here is the one that I did. You're probably going to get different versions because WebAssign randomizes the question. So you may get 6 and 1.82 or something, but it'll be the same basic question. You see the various fellas. think I got 4.28. You notice that's all you actually would be writing down here. So all that working that I did, or all the stuff that I did in my calculator, I needed to do it, but I don't need to. There's nowhere in WebAssign that I would write all that working down, right? It doesn't look for it. It's not looking for it. So that is good. Here is an example of the same thing, but it's now done using a table. So when it's a table, don't you basically just find 2 and 4, which is what this guy here and this guy here. So it would be what, 50.2 take away that, divided by 4 take away 2. There's no shortcut, you just do it. And you write in the answers. And then in this case, you're interested in what's 3. So if I was looking at what's in 3, you would probably want to pick some of these numbers and maybe average them out. 5 is easy. You watch a video and you do what they tell you to do. And question 6 is watch a video, and you it takes you through the process. So there's not an awful lot in this. As I scan through it, it looks like you put a number in here, and then you put a number in here, and you put a number in here. And most of the rest is done for you when you just watch it.